Okay, folks, we're live. Welcome to another edition of SpaceAg Conversations. Thank you for your patience as we got started a couple minutes late today. But we really appreciate your participation, and we hope we have participants from all around the world. So please let us know in the chat where you are joining from. We always love to see where our different participants are joining us from.
Hi, everyone. Glad to have you all here. Maybe David, do you see if maybe you need to enable the chat for the participants to send?
Let's see. We have our, let's see, how do I do that? Okay, I think Nico's going to take care of that. So thank you, Nico. If you can take care of that.
Yes. I believe now everyone can send.
All right, well, this is, SpaceAg's Conversation number 5. And we were going to discuss with our amazing guest SpaceAg initiatives in the Middle East. All right. We have someone from Pakistan, from Turkey, from Mexico, from Lebanon. Ooh, they're coming in so fast. Canada.
Oh, nice.
Hi, everyone from all around the world. Glad to have you all here today.
Okay, I am joining from California. Davi is joining us from
Turkey as well.
And our special guest is
And
joining.
I'm joining you also from Jordan.
Okay, amazing. Let's see. So today's webinar will have a short introduction, where we'll introduce our guests. Then our special guest will give a presentation, and then we'll open it up to question and answer, where you guys can ask questions via the chat or via the question. And then hopefully we'll have time to get to all of your questions, and then we'll have some closing remarks. We really appreciate if folks can stick around all the way to the end. We've had an amazing number of SpaceAg conversations already. This is number 5, and all our previous episodes are available on YouTube, so please check them out. Nico or Davi, I'm sorry.
Yeah. So together with the SpaceAg Conversations as part of the SpaceAg series, we also had webinars discussing the updates about space farming. And as you can see, we discussed opportunities in the field. So for those who are interested to join the field as a professional working with a space farming related company, feel free to join and to watch these previous webinars. We also have news reviews and so on. So, with all of that, feel free to jump in the chat and let us know what was your favorite episode of the SpaceX series so far. So we had many speakers, many interesting conversations, and feel free to let us know which was them. David, you can.
Yeah, and if you have ideas for speakers, please reach out. Let us know if you think there's someone that we should interview on this webinar.
Yes, for sure. And well, today we have an amazing guest speaker that will be discussing with us his efforts as well as his perspective about the field of space farming in the Middle East and how Middle East is and can contribute to the future of sustainable space exploration. So, Omar, Welcome to the SpaceAg Conversations. It's a great pleasure to have you with us. And feel free to introduce yourself and proceed to your presentation.
Hello everyone. Nice to meet you. Thanks, Davi, and thanks, David, for the introduction and initiating this. I actually watched all of the episodes from before, and they were quite interesting. I hope I can keep up with what was going on there. My name is Omar. I'm from Jordan. I did research in many different places where my focus was actually first water, and then it was urban farming. I'm a civil engineer by profession. I jumped ship into farming because I actually felt the need for it. So what pushed me to do this, what pushed me to start iPlant, working on research, was actually the constraints and limitations when it comes to farming and agri-tech in Jordan and in the MENA region. I'll do a little bit of presentation, trying to connect the dots and trying to connect how what's going on here can actually contribute eventually to how we farm and how we grow food in space and beyond Earth. You'll see from my projects, it's wide range of projects. I work on different products. It was always a thing. I had always this joke when I started urban farming that I started the controlled environment agriculture. Then I'll show you a project where we actually did some farming underwater. So I was always looking to also be connected to farming in space, and hopefully this can be a first step towards what we will do. I'll share my screen now if it's
So
possible.
you are maybe the first person in the world who's farmed on land, in water, and in space, right?
Yeah, hopefully, if we send one of our units to space, this is something hopefully I'll be able to say. And actually, this is the thing. It's the same. It's growing wherever. It's a controlled environment. We try to control the different variables and we try to fit it into the environment we want to grow in.
We should,
Hopefully, everyone can see my presentation, my slides.
yeah, we
Okay.
should call that the farming triathlon, right?
Yeah, yeah. Maybe we'll work on that, David. Uh, uh, to be honest, whenever someone wants to ask, I don't mind if you write it in the chat, or even if you see it's too relevant, Davi, unmute wants to talk, and feel free to feel like it's a live conversation. Okay, as I mentioned, I'm Omar. I'm one of the co-founders of iPlant. Uh, I've been working in the Middle East in the farming industry for the last 10 years, a little bit when it comes to water efficiency. And I'm happy to be part of this. This is a picture of our two units that we developed in the last couple of years. Each one had different customization based on what we were looking on. I'll be explaining most of it later. Uh, okay. So my my background always connected urban and greenery into our daily life routine, and one of the main reasons I was working on green roofs and green walls is actually that it changes what people feel when they are around this kind of greenery. There were previous research even on land, even for exploring the space industry, where they actually proved that adding green walls or green features inside the offices can increase the productivity. This is only on what's going here, and you can imagine how adding this life and greenery in space and in space missions, in space stations, can actually also contribute to the livelihood of the astronauts, not only from nutrition perspective, but actually from how they feel about it. Interestingly, I worked how different water sources can affect hydroponic systems. This is how I got involved with hydroponic systems. I explored different sources of water, treated gray water, tap water, harvested rainwater to see how each of them actually affected the yield and the growth of the plants. Interestingly, harvested water proved to be the best. Rainwater have some kind of chemicals that actually can increase the efficiency. This is what we found in our research. Also, we were exploring how water that is coming out of green roofs can be used and treated in general. Why the Middle East? Why it's a challenge? Why food and water are actually one of the main problems that we need to tackle in the near future? In the Middle East, 12 out of the 17 most water-stressed countries actually lie in the Middle East, including Jordan. Jordan, this is actually 90 meter cube per year, actually is above what is declared in our news. We go around 60 meter cube per year, which is almost 10% of the needed threshold by the extreme stress to water. Also, when it comes to food production in the MENA region, 50% of the food is actually imported. This has been showing a huge problem, especially with the COVID. This disrupted the supply chains. This disrupted the availability of the produce. Thankfully, in Jordan, we didn't suffer from it that much. We had different way we dealt with it, but it wasn't impacted. But countries like Saudi Arabia and Emirates had a big impact on their economy, on the prices of the produce during that area. Also, the climate stress and the climate change are increasing these challenges. We are expected to go by 2 to 4 degrees by 2050 in the Middle East, and this is actually really significant when it comes to growing food. Like some people will think, okay, it's 2 degrees, but actually 2 degrees disrupts the whole growing process, the seasons, everything when it comes to the plant physiology and biology. So this is how it started with me in Jordan, because when we design farms in Jordan, we always start with the water. The first question is, there is water? What is the closest water source? And actually, this is the same logic that we can apply on space agricultural design. We have limited resources. We need to start from there. We need to make these resources used efficiently inside the systems. And this is, again, something we deal with on a daily basis in Jordan. So how this can contribute, how the MENA is poised to leapfrog in this agri-tech revolution. Again, necessity drives this innovation. There is a lot of innovations that are coming to surface now in the MENA region, and each of them is actually connected to one problem specifically. It targets solving a problem related to energy, water, or even labor constraints. The government drivers are actually kind of the main, also one of the main reasons why this is actually escalating in the area. Governments like United Arab Emirates, Saudi Arabia, they are funding innovation in agriculture, and this is again to solve their own problems. And most of these innovations can be applied to our technology when we are trying to implement it in space. And actually, the mindset, like we always were talking about how limited we are, but now the people are talking how we can be efficient. I can see it even in the last 3 years. People are looking at problems differently, trying to solve them. And one big contribution to all this is the AI evolution that is happening, integration of IoT sensors, the agriculture 4.0 revolution when it comes to monitoring and control. All these are making this thing closer to reality. We are seeing things now, farming practices that would have looked like science fiction 10 or 20 years ago, but people are doing it. This is actually just one of the units we worked on. I'll explain it a little bit better, but we actually built it for limited space, limited water, limited energy in Jordan, and we think this can actually be integrated into off-Earth habitats. Also, the investments and the funding is actually going from growth to efficiency. These are numbers from the Water Innovation Report in Asia and Middle East. We can see that when it comes to water and food tech, the investment is bigger. People are more driven towards impact innovations. Fortunately, this is happening due to different reasons. There are a lot of projects that are happening in the area when it's related to gray water reuse in agriculture. How can we regulate it? how can we incorporate solar energy into the practices we are using, especially that when it comes to MENA, we have almost 300 days of sun. So this makes even the systems more efficient if they are integrated into these renewable resources and sunlight. And more startups are working in the urban farming sector, making controlled environment agriculture something that they understand and they deal with on a daily basis. Recently, when I came 3 years ago to Jordan, there were barely any controlled environment agriculture rooms or units in Jordan. Unfortunately, now we have more than 12 sites, whether it's for iPlant or other agri-tech innovations that are working in the sector, making it available to the researchers, making it available to the public, and increasing the awareness. One of the things even we at iPlant we work on is educational programs for students. We want this new generation, when they are in power or when they are thinking to start their own businesses, to keep these things in mind and to be integrated into what they want to do and what they want to learn. Again, I talked about this, the government-backed innovation. We can see the Food Tech Valley projects and the strategy up to 2050, where they want to supply more than 50% of the produce to be inside the Emirates. Also, the 2030 by Saudi Arabia emphasizes on vertical farming, indoor farming, controlled environment agriculture, and even integration with research towards space agriculture. Also, even from our own experience, we are noticing more collaboration between startups, organizations, and academic institutions. During my work at iPlant, I also worked as a consultant with a couple of projects that are happening from NGOs, from the UNDP, from the Scientific Society for Research in Jordan, and all of these actually contributed to developing our own systems and developing the systems there. This collaboration, I think it's one of the main drivers when it comes to actually piloting these innovations and trying them on Earth and customizing them towards space farming. Just a note, like actually, were these 12 or 14 countries that are suffering from water stress. In the Middle East, we produce almost 40% of the desalinated water. And now we have verified tolerant crops that are transforming these deserts into farms, into production areas, into farming oases. And this is actually the same. Most of this research, when it's connected, it can be simultaneously adapted to space research or space farming. Here we come to iPlant. What we do, we are, as I mentioned, the Jordanian agri-tech company. We're working on smart and automated vertical farming solutions that are tailored for the arid environment in Jordan. We work with controlled environment agriculture. We have developed our in-house developed controller and automation systems. We just started actually working on integrating image processing and AI into our controller to monitor the growth rate and expect diseases. And I want to show just a few of the product. This is our unit. We call it HUG, a home urban garden. With a 2-meter footprint, 2 meter square, it can grow up to 300 plants per month. We save up to 90% of water, and this is something I would like a bit to talk about. We actually, even in our pilot farm, we have dehumidifiers that actually collect the water from the room and adding it into the system, making the system almost run on zero water. This is, of course, different when it comes to space with the lack of humidity, but eventually, like that circular concept of the system is there. We use LEDs. We are actually connected to the solar PVs that we only run the systems and the farm when renewable energy is available, making it run on zero grid power. And we are trying to adapt it. We have a closed version, we have an open version, And we are trying now to find collaboration where we can actually try implementing these solutions, and at least for now, in some analog mission in the area and around the world. This is one of my favorite products. We call this Greenspin. Basically, it's a carousel movement unit. There is a video just to explain how it goes, but the main driver for developing this was actually answering the question, how do we connect vertical farming with sunlight? As I mentioned, we have a lot of sun. If there is a way to connect both, it will be great. And this is what we are working on. Basically, it's a carousel unit. Most of the plants would go and be exposed to sunlight, and then they will be irrigated at the bottom layer in a circular motion. It can fit into a container, and when it's a container, we are talking about an open top container where sunlight can actually go into the farming operation. Also, you can add supplementary LEDs to the system to increase the efficiency, or where sunlight is not completely available. This is a video we did for the unit. It will be now clear how the system actually works. So basically, we actually work on this unit with the National Agricultural Research Center in Jordan. It's there. We are experimenting. We are doing different experiments for the unit. For example, now each of the trays have a different depth for the water. And we are hoping that can give us an answer of how much water in this NFT tube can be best when it comes to growth yield. We are experimenting with spraying fertilizer from the top also. And as you see here in the end of the video, the harvesting process. One of the main advantages of the unit is that, I'll go back to the picture. One of the main advantages is that you can actually harvest and plant from one side of the unit. So this unit can be attached to any habitat, basically, as a concept. And then the farmer doesn't even need to go into the farm itself. All the trays, all the plants come to the door. They can plant and harvest. And this is interesting because whenever we are doing one of these projects, then we get interest from different people that have a different value proposition to what we are doing. For example, some people, we got contacted by an agency for movement disabled people, and they are thinking to incorporate this into their environment. They want the people to grow food. And one of the main things is that they don't need to move around the farm. So basically, this provides them with a chance, with a limited space, limited water, limited energy, to actually have a farm. Another project that we actually did, we implemented this project. It's called iGrow. It was implemented with different partners, including the National Agricultural Research Center, iGreens. Basically, it's a circular concept. We try to connect all the resources into one circular loop. So here on the right, you can see a gray water treatment system that was designed by the Research Institute, and it collects all the water from the sinks in the building. And after that, the water actually gets treated in this two vertical farming treatment processes. The water goes to irrigate this green roof. And after irrigating this green roof, it gets filtered and went into a hydroponic tank inside, where the hydroponic tanks can operate this hydroponic system. Afterwards, all the excess water is actually used to irrigate the surrounding landscape. So basically, what we are doing here, each drop of water after being used in the sink is actually used in 4 different processes before it's actually irrigating the landscape. And this is why we feel the connection. Like, water isn't available all the time. Water isn't available in space. The more that you can use it, the better it becomes. And if we are tackling at least the water aspect with the innovation here, I think this can be a big part of the puzzle of how we can actually survive and do farming operations of Earth. Also, within the system, all the system is actually controlled by a controller to monitor everything, including CO2, water level, air temperature, the hydroponic tank, pH, EC. So all this is connected to the same platform. And this actually gives us to compare everything. Even we are trying to see how the green roof is affecting the temperature inside the room. We are trying to see how the water is affecting the gray water is affecting the growth of the hydroponic system. So these results, these kind of confirmed calculations that we are doing can actually also contribute to going into farming operation in space. This is another project we worked on. This is the underwater farm we did. It's still in research. We finished the first unit and now we are working on the second one. Basically, it's a completely closed environment. So this is underwater. It has some air pumped inside, and the farm actually operates by itself. It's completely automated. We have the results here. One diver needs to go once per week to check on everything. But one of the few ideas and the constraints that can happen here when we did this project was actually the humidity. So basically inside the dome, the humidity can go up to 100%. It's completely saturated. So basically all of our systems were just, going crazy. They operate one day, then they are not operating correctly. Eventually, we needed to deal with this, and we needed to seal everything so that the humidity doesn't affect it. Again, this uses actually it can be connected to solar energy, so it uses zero energy almost, just the pumps and the supplementary LEDs. Actually, or even the water is actually condenses on the inner surface of the dome, and it's collected in trays around the dome where it goes back to the tank. So also there is no need to continuous water feed. It does it by itself from the humidity. And this is something that I don't know, like most of the people, when they see this picture, they think in space, it's not in water for some reason. But yeah, we are hoping actually to explore this further and see where we can go with this.
One question for you regarding that.
Yes, yes,
You
please.
say the research focus was plant response under pressure and isolation. What do you mean by isolation?
Because it's so if one thing we noticed, we even at the harvest seeding stage. So we compared the same seeding under the dome, and we planted some seeds above, and they were completely different. The humidity inside, though it's isolated, the humidity inside the dome was too much for the germination, we believe, and it didn't germinate well. On the other side, on the other hand, when it was in the growth process, actually it performed better than it was outside. So all the variables can affect the different stages. And one thing that when it comes to isolation, that this unit is completely, we tried to seal it, and actually bringing the seedlings from outside actually brings some kind of insects or whatever. So we tried to do everything inside, but it didn't work. So we are trying to optimize it now. But again, like we are it's all everything changed since we started the project. A lot of the processes didn't work or did work depending. Even the leafy greens, when it comes to leafy greens, some of them were performing much better. By the end of the day, actually, just something to explain. This is 9 meter above 9 to 10 meters below sea level, below the sea level. So the sunlight is actually quite good. It's not too much. It reaches in, so we didn't need even the supplementary lighting. We were doing it just at night, but also it was interestingly attracting all kinds of fish and animals. So we actually have a live video cam that we used during the first couple of harvests, and we were watching, and most of the fish and the sea creatures would come because the light was on, and they will stay will stay there. So it was interesting, but again, like I would imagine something like this being tried out in outer space with the same constraints and same situation. And we actually one thing we actually connected also internet to the dome. underwater. So we were able to communicate with the divers while they were doing maintenance, for example, or doing some consultation or checking the plans. So it was quite an interesting project, and we are hoping the second one will even be, hopefully, will be better. And hopefully, we'll have another talk by then, and it will be dedicated to that one. Uh, so yeah, so and how does all this come to connect it to what we want to do? How do we want to connect what we do at iPlant to exploring space farming? Uh, Now we are working in different locations, but one advantage is that most of the locations have their own control and monitoring systems. So each of these different environments, whether it was on a rooftop, whether it was underwater, whether it's in a CEA room, it's being recorded, and we can actually start comparing these results. We are trying actually also with AI to work on a digital twin version to all these farms so that we can actually have a virtual and connected database that we can actually optimize what's going. So, for example, maybe we can try adding 2 hours of supplementary lighting to the dome, or we want to add, all this would depend on the results of the other farms. And again, like now we are seeing more collaboration and research when it comes to, we have more than one farming initiative. One of them I was working, hopefully it's in the slide after this. Yes, MENA.org. I was working with the food department. Unfortunately, I didn't have time, but they just had their first analog mission in Wadi Rum. I don't know if you know, but Wadi Rum is one of the closest habitats when it comes to the visionary to Mars. And they try to uh, create a similar environment. They did it, I think, for 7 days. And it's a great start. I believe it's a great start. They have a great team. And one part of the project was Rivora. She's my friend, the co-founder. She's a German, she's from Germany, the startup, and they are trying to also work in the agri-tech, and they were working in the MENA analog mission. And we are hoping to actually collaborate with them in the near future. So yeah, let's collaborate, whether you are a researcher, whether you are a farmer, whether you are a scientist. I think it's the chance for everyone to be working on something that can bring this together. Innovation is what drives this. I don't think um, now, with everything that is going on, I don't think we have that much of limitations that we had before. We can work on different solutions. We can harvest water now from the air. We can actually harvest water for farming. We can engage with the community, do programs, increase the awareness for the new generation. Actually, the organization I just mentioned, they are more than 200 volunteers. This shows the passion, this shows the interest of the people in this kind of studies or career path, and it's quite uh, great to be in this time, actually. So thank you. You can find us on LinkedIn, social media, Instagram. Feel free to contact me through LinkedIn, through WhatsApp. My info will be available. And thank you for giving me the chance to have this talk. It was great. Hope everyone uh, got something they needed, and hope it was interesting.
Thank you so much, Omar. This was super interesting. Um, I have one question to maybe start the Q&A off, and this could go for both you and Davi. Um, so you mentioned that when you um, think about design, you operate or you think about what's the scarcest element, right? And so in Jordan, obviously, it's the water. But when you think about space, what is for you the element that's that point of scarcity that you would start your design with?
Should I start or you, Davi, can start? I'll
Feel
take a
free,
break. You
Omar.
can start. You can start. I'll answer it after.
Okay, okay. I would say that in space, one thing that is it's clearly necessary, like in an engineering point of view, I would say that is standardization. After all, like for example, for sure you have like different challenges that you need to provide a system to operate under that specific conditions, and this will be translated into engineering requirements. And I would say that what are the engineering decisions that we could take that will allow us to handle, at least solve most of these requirements? This would be my answer. Like in space, we have like what I can say is that I usually say that for example, what we know about space farming is what the researchers, the scientists learned, and the astronauts learned at the International Space Station or during the space shuttle missions. So we will start learning things, more things when humans reach the moon very soon, and afterwards Mars. So like there might be challenges that we do not expect yet. So how can we make the systems more flexible and standardize it in terms of like to like be like solve a specific challenge that we were not expecting? And if we need to change a specific solution, like okay, this I will give a hypothetical example. Like this LED system is not working anymore. Like it's not meeting the conditions, the light conditions that we thought we would need on Mars. And how can we replace it very fast and in the most feasible manner? So I would say that in the engineering point of it would be standardization. Omar?
It's interesting for me because when I think about it, I think water is still an issue, but then there are a lot of issues when it comes to space. But interestingly, like if you think about any of these limitations, then now you are seeing different solutions for the same limitations. So, for example, if I want maybe 20 years ago, if someone asked me, I would say there is no soil, the soil is not good. But then you look at it now, then there are different solutions. They can optimize the soil with good microbes. They can modify it chemically. Also, you can do hydroponics. So for the same limitation, we are seeing different innovations. And I think one thing that will make a difference is integrating each of these innovations with each other. So, for example, again, there is different solutions for solving the water problem. We can do water harvesting from the habitat because there is some humidity, and we can add some water. We can take some water also for use. But by the end of the day, if you're taking 1 meter cube of you have 1 meter cube of water there. What are you going to use it for? Are you going to use it for farming, or are you going to use it for daily routine, or what? One thing to look at it differently is that you can use it more than once. So basically, you can use it for cleaning, a little bit of treatment. You can use it for irrigation or for the hydroponic system. So how we look at the problems, thankfully, now we have the options in front of us. When it comes to sunlight, like LEDs, when it's supplementary lighting in general was too expensive from an energy point of view. And then the LEDs came, the LEDs, then they solved the part of the problem. So the I would actually look, if I want to start working, as Davi mentioned, needs to be standardized. I need to have all the data in front of me to be able to actually combine these and see how they come up with the most efficient system. Eventually, it's a closed environment system,
Yes.
it's inputs and outputs. And the more you can control these, monitor these on the ground, actually, and be able to control it completely will give us a chance to actually apply it as it is, I think, in the space.
Yeah, excellent point, Omar. Actually, excellent presentation. It was very exciting to see what you have been doing, and how much impact you are delivering to not only to MENA region, but to Middle
Thank
East
you,
and
Davi.
to the whole world. So we have some questions here. I would start linking with something that I believe that during my period working in Saudi Arabia, I saw that one of the main points to have into consideration when we are dealing with food security in this region is local food production, because it's easy to buy food from uh, externally, like from external sources, but how to deliver, like the Middle East realized that, okay, we need to grow our own food to enhance our food security. And to make this local food production is the same idea as we will have like on Moon and Mars. And you discuss some of the, like, let's say, consequential like things of this. Like we need to have a good source of water. We need to have a source of renewable energy. You mentioned like about the solar panels and so on. And I will connect this with the question from the audience. Which is, what kind of mitigations are expected for MENA region to improve this business case? Like how the Middle East can deliver more, considering these similarities, how do you think it would be like the region could deliver more solutions, could be more within the sector, the space farming industry, contributing even more to the space farming industry?
Okay. Actually, in our 5 minute talk before the session, we were talking about something, and unfortunately, when you look about integration on in the news, or you see big news about the biggest vertical farm in Emirates, the most advanced indoor farm in Saudi Arabia. These are concepts that are being developed, as you mentioned, to for food security reasons, and they have the funding, and apparently they have a business. Like one thing I mentioned, like vertical farming or indoor farming in the Middle East is actually completely different. Like it's hard to when there is another option, maybe you have an argument, but when it's the only option, eventually it needs to be optimized. I always thought like this happened to most of the industries. Actually, solar panels, when they started, it took them 20 years to actually be efficient. It's not a fast thing, but actually putting money in innovating these technologies when it comes to vertical farming or indoor farming can actually shorten the gap. The innovation that happens on the ground, I believe it eventually can contribute. And this is, let's say, using this money for a dual purpose, not only for indoor farming or vertical farming or farming or even earth. Like they can now integrate it into the space research or space operations, especially that all these initiatives are being initiated in the last couple of years when it comes to space. So hopefully more people, you know, one interesting thing now, when the uh, space organizations start, they actually, most of the time, they need collaborators, Most probably they will be experienced in a couple of aspects. Let's say when it comes to analog mission, they know how to design a rover and how to actually work out the automation and control. But still, there is the farming, there is the suits, there are different things. When these options are available in the local market, it's easier to integrate. I mean, if they are creating, let's say, the first big analog mission in Saudi Arabia in 2026, eventually to build the system, they need the hardware, they need the experience, they need the software, they need everything. Most probably they will have some of them, and most probably they will look for the rest. If these things are already being studied or researched or actually piloted in our area, it will be easier to integrate for both sides. It's a win-win situation. And this is actually how I do with iPlant. Like we started iPlant with no connection whatsoever to the space farming industry. The more we got advanced in what we do, we found it closer to what's needed, let's say, in space. And this is, hopefully, we need someone to also help bridge this gap, whether it's research, whether it's government, but the possibilities are endless. There are a lot of even new startups when it comes to different kind of things, laser communication, material science. All these can be integrated to fit into a system. And collaboration between startups is also I encourage it. Like it's interesting to work on new things, even if nobody did it before. But actually exploring it and getting the support you need, nobody can do anything alone. Collaboration is a key. I really believe so. Startups, industry, academia, and eventually, hopefully, we see more projects in the near future, especially when it comes to space farming.
Yeah, excellent point. I would say that it's like there are many people doing many things and exploring many things, but sometimes they do not talk to each other, and that's why I mentioned like standardization is very important, because like if everyone speak the same word about different, like about about the same challenge, but like if everyone speak the same words, like it's easier to understand and like deliver more solutions for the different fields.
I
So
think this is
yeah, go
sorry,
ahead.
Davi. This is what helps. This kind of conversation with people who are watching, that they have their own ideas, they have their own concept. Someone can actually connect with this, and hopefully, we as co-founders or researchers can actually make this connection. Like it's great to actually explore this with more people, and hopefully I believe this is a chance for anyone who wants to be in this sector, to have people to connect with through these webinars. Actually, I really liked the ones before. I learned a lot. Even for me, 90% of the information was new, and this is quite interesting. I really think what you are doing, guys, are great, and it's helpful to exactly answering the question that was actually mentioned.
Thank you about that. There is one question. It was during your presentation. I will merge them because they discuss about kind of the same topic, which is the water. So, how do you measure the water demand from the plant or the plant activity regarding uptake in the substrate? I will condense this in in a big question, like how do you measure the water quality and how you see like it's the best option to deliver the most the like water with more quality? What is necessary to be done in terms of control? Let's say like in the future on Mars, we have water available in the poles of Mars. So what do you think would be necessary to harvest this water, like, and deliver the most efficient solution for
Okay.
agriculture?
Uh, okay. In most of our projects, like our main focus when checking quality or quantity is water. And thankfully, the technology and the hardware is developing really fast. The more control and sensors you have on your system, the easier for you it will be to actually find a way to calculate everything. So, for example, in one of our units, we measure all the water that comes from the tap and all the water that is coming from the water harvesting dehumidifier unit, and we even connect the water from the AC units, So we have everything measured, and we actually try to see if we can actually be sufficient with only the renewable source or the source that is not having a demand on the quality. Interestingly, another thing that we did that was a part of research, we actually explored how AI can actually optimize the resource use, but it was actually focused on energy. So we are trying to see if we can make the system more efficient if the system learns when to get electricity from the grid or get it from the renewable. So this is again something that is quite interesting, using AI in the controlled environment industry, not from image perspective, not through machine learning from images, but actually from the data you collect from the sensors. Uh, I don't know if I answered the question as they want, but again, like I'm happy to answer if there are anything more.
Sure.
What kind of substrate are you using in your iPlant
It's
systems?
it's mainly rock wool. So far we've been using rock wool. We tried different kind of substrate, but for let's say hygienic purposes, rock wool always proves to be actually the best.
Gotcha. Gotcha. We have a question about says what happens when UVC reaches the plant in Mars from the sun? So on Earth, the atmosphere is stopping that, but if you had plants on Mars, what would happen when the UVC would reach those plants? Do either of you guys know? Can answer that?
Omar, would you like?
I It's maybe not my thing. Maybe you should, but
Okay,
I know they
sure.
can block some radiation using specific glass or
Material.
modified glass to actually block this kind of radiation. But I don't know where the technology actually reached when it comes to that. David, please.
Yeah, basically it's like the cosmic radiation. That it's not necessarily from the sun, but of course we have the ionizing radiation that reach the plant material, and it changes the like the plant material it modifies the genetic material of the plant and yes, it's this was one of the most impactful things, and like of course this would impact the growth. Like this impacts from the seedlings, the seeds if they are like exposed too long. This is also another point. Time of exposure, like how long we are exposing these plants. Of course, if it's a trip to Mars, this would last like about 8 months. So the seeds or these plants would be exposed for long terms, but of course, as you mentioned, Omar, like they have a lot of radiation shielding technologies, materials to avoid that. But just to point out, like a common thing that is done, like is conducted as type of research, is exposing plant materials, seedlings in space, low Earth orbit, to evaluate exactly like what would happen to the seeds or to the plants once they are exposed. This happens at the International Space Station. Blue Origin send seeds like one part of one of their missions. They send some seedling materials to evaluate also to see like what these changes in the plant genetic material. Um, and yes, basically, this is also another point. Like you suggested, Omar, to bring like other examples what is happening at the Middle East. So there is currently a group of research in the King Abdullah University of Science and Technology. They are building a radiation chamber basically in the lab exactly to evaluate the impact of like radiation in the microbiome, exactly like to see what happens to like bacteria, stromatolites, and so on. Like they are exploring exactly this topic, and this is happening exactly in Middle East, in Saudi Arabia. So, um, as I mentioned, like many topics, uh, some people might try to understand what is happening to the radiation exposure on seeds, other ones to the plant materials, like how this would affect the plant growth and so on. So these
I
were my
mean,
my
Davi,
points.
Davi,
Yeah.
interestingly, this all this kind of also affects, like this makes everything beyond Earth quite different. I mean, the exposure, how close is it to the sun? Are we talking about the moon? Are we talking about the sun? About
Yes.
about Mars? Are we talking about the space station? Each one of them, specifically when it comes to radiation, is quite different. And I think whatever we are building here needs to be optimized to the environment there specifically at that point.
Yeah. Exactly. Like it's intensity and exposure time. So like we need to consider this. At the end, these are like stressors, abiotic stressors that will influence on the plant growth, of course, and like understanding this as you mentioned, the inputs. Try to control this, like reduce the impact on the plants to enhance the outputs. I would say that these are the main things related to radiation. So I think. With the like the radiation topic, maybe we can go to the last question and go to the closing remarks. There's just one more question. I think it's interesting, especially regarding the system that you develop, Omar, um, regarding the rotational one
Yeah.
and the similarities with gravity. So there is one question about the effect of gravity on the system on plant physiology. So what do you see about that, and especially like how your system could be useful to understand the effects of gravity, reduced gravity on plants?
Okay, so as like the rotational system actually, the plants are actually attached to the tube, so they are not loose because with the movement you try to make them as stable as possible. Another thing is the water, actually the irrigation water. So what happens is that most of the trays, when they go up, they are empty of water, but the rock wool around the plant roots actually keeps the water kind of in place for it not to dry up. The whole rotation takes almost 45 minutes. We want to make sure that the rock wool and the roots never gets dry during the rotation, especially when it's because it's in a greenhouse and it's actually quite there's quite some sunlight here and it's quite hot during the day. I think this is something. Another thing that was also discussed most of the time is if we switch the movement into a rotational one completely rather than the up and down system, and this might be more interesting because you will switch the orientation of the plant during the growth, and we believe this can actually cause some stress that might be similar to the stress that happens from the unavailability of the gravity. There are people working on this. There are a few systems actually also, I think, exploring in a non-gravity environment, how the plant, how the roots actually move around, how the water attaches to the roots. It's still, this is something that I believe really needs to be explored. And one thing, like, if I'm running the system, these small difference, they might be not small, but the differences we have, they don't affect the plant in live or die manner. They kind of reduce the yield over time. They kind of if the harvest like only by switching the nutrient solution in the system, we tried two different ones, and one of them it took 28 days for harvest and the other took 31. And when talking about all the other environments, they some I don't know what can actually cause an extreme stress to kill the plant, but most of the time it will be just a shock and it might recover. So it's something I think we need to explore. It's hard to do any experimentation with no gravity here, but if someone has a no gravity room, I would happy to ship our system and we can try it there.
Yeah, totally understand. David, can you please share the screen and we
Yeah.
can proceed with the closing remarks? One last point, one thing that I would like to point out while David is doing that. Thank you for the questions, everyone that is interacting here in the chat and so on, like bringing questions, participating in the discussion. We are very glad, like, for your participation here today. And remember, like, similar as radiation, gravity is also like can be also a stress, and the intensity, of course, like on Moon, International Space Station, Mars will be different, such as here on Earth, but also times of exposure.
And
So,
the same thing with your CEA operation, right?
exactly.
You change the amount of time your plants are exposed to light. You change the lighting cycles. You change your temperatures. It's going to affect the plant physiology, and you're going to get different results. So
Exactly. Exactly. So, if you are here until now, so just the closing remarks of our webinar. If you got interested in these discussions and want to learn more about these topics, get more into the field of space farming, space ag, we have the course, the Space Farming 101 or the SF 101. which discuss from the systems, engineering, design, the plant physiology, the stressors also that the environment can cause on the plants, and also the relationship, as David mentioned, the synergies between the space controlled environment agriculture and also it's related here on Earth, how controlled environment agriculture can contribute to the future of space exploration. So we have a lot of examples, really good discussions on the course, and it's available on the architecture design software.
Yeah, this is a great course. It's done by Davi, and you can learn a ton. So really encourage everyone to check it out.
Yes. Together with that, we also have the newsletter, the monthly newsletter, which will bring the discussions, the recordings as well that will be available on YouTube. We share the link, we share the video afterwards in the newsletter together with other topics related to the field. So if you are interested to join our mailing list, feel free to mention here in the chat. And David, you can jump.
Yeah, if you want to take a leafy greens masterclass, if you really want to master growing leafy greens, there's a new online course. The classes are 4 2.5 hour sessions beginning next Wednesday, I believe. But more information by check out that QR code. And so if you want to master growing leafy greens, please check out this new course that Agritecture is launching.
And finally, we offer a certificate of participation for those who stayed with us until now, who participated in the webinar. So I would drop here the link on the chat. You can answer the form, and as part of this answer, we request to our guest speaker a keyword for the participants. So Omar, feel free to let them know.
Let's go with my favorite thing, water.
Water, great one, great choice. So the keyword is water. So for those who want to receive the participate, you need to answer the form. Also in the form, you can highlight that you want to be part of the newsletter. And I think with all of that, one next slide. Yes, we would like to thank you everyone who participated. Once again, thanks Omar to
Thank
be
you
part of it.
for
It
this.
was a great pleasure to have you with us, to learn more with you, and thank you all.
Thank
Thanks,
you everyone
everyone.
for attending. And thank you, David and Davi. This was great. I really enjoyed it. And hopefully it can start some different kinds of collaborations with everyone.
Excellent. So everyone, thank you so much for joining us. We'll hopefully have another SpaceAg conversation or SpaceAg update in a month or so. But please keep an eye out for announcements on LinkedIn about future sessions. And yeah, everyone have a wonderful day. Take care.
Have a good day,
Bye-bye.
everyone. Bye-bye.